Hello, family. My name is Des, and welcome back to Combined Science. And we are doing the physics section, and we are working on motion. So we are finishing off where we left off. There's so many offs right there. But anyway, we're gonna have a lot of fun today, and we're going to learn a lot. So let's dive in. We're talking about motion today. This is part 1.2, the B part. We did the A part. If you didn't watch that one, please go back and check out that one so that you this is just a continuation of that part. So let's go. Okay, so we want to talk about plotting and interpreting a speed time graph. Plotting and interpreting a speed time graph. So let me just go ahead and get my laser pointer. So what we are doing here, really, I want us to just maybe work on these definitions before we get into that. So the first thing that I want you to understand is we have been using the term speed time graph and things like that. But I want to introduce two new terms. The first one is velocity. So what does velocity mean? Sometimes you see that it will be used interchangeably with speed because it almost means the same thing. Velocity is speed in a given direction. So velocity is speed of something in a given direction. Then acceleration becomes now the rate of change of velocity. So velocity, we are really talking about speed just in a particular direction, right? Velocity is 20 kilometers per hour to the north. That's velocity, just in a given direction, right? And then acceleration is now the rate of change of that velocity. So if we are moving at 20 kilometers per hour and then we change to 50 kilometers per hour in 1 hour, that's the rate of change, right? How much time did it take to change from 20 kilometers to 50 kilometers? That's what we're calling what? Acceleration. How much change is happening in a given space of time? So we're going to calculate acceleration, and we're going to get into all of that, and you're going to see it. So when velocity is increasing, then what we have is positive acceleration, right? We are saying our velocity is changing, but the change is happening in a positive manner, which means our velocity is increasing with time. So that's positive acceleration. And when it's decreasing, that's negative acceleration, or it's called deceleration. So negative acceleration, we call it deceleration, which means the velocity is reducing up until maybe the car or whatever it is, object is that is moving, comes to a stop. So when we're looking at the speed time graph or a velocity time graph of a moving object, what we find from that graph is we find the acceleration of that object. So when you're looking at a velocity time graph, so for example on this graph, this is velocity in this side and this is time here. So if you can see that the velocity was 1 here, it was 2 here, it was 3 here, it was 4 here, it was 5 here. So the velocity is increasing with time, right? So the speed is increasing with time. And so if we calculate the gradient, remember we talked about gradient when we did distance time graph. The gradient of this line, if you calculate the gradient of this line, we say y2 minus y1 over x2 minus x1. If you didn't get the one, please go to the previous video on motion. You will get the gradient. So if we calculate that gradient, you will find the acceleration of what that was taking place, the rate of change of velocity, how much speed was being added on per unit time, right? The rate at which the speed was increasing, you find it when you calculate that gradient of this graph. And then here you can see that the velocity is 5, right? And so it means that there is no increasing in velocity, which means the object or the car, whatever it is moving at a constant what? Speed, which means there's zero acceleration, constant velocity, zero acceleration. And then here we are seeing that our velocity is reducing with time. So this is negative acceleration, and it's called deceleration. So basically that's what it is. Then if you calculate the area under this graph, so if you calculate this whole area, right, the area under this graph, you'll be able to find the distance that has been traveled since this time up until, from this time, which is 0, up until this time. So if you calculate the area under this graph, you'll find the distance that has been traveled. So one of the ways to just calculate the area is just to calculate this triangle on its own, half base times height. Calculate the triangle, you calculate this rectangle on its own, right? And then you also calculate the area of this triangle on its own, and then you get the area under the graph, and that area is equals to the distance traveled. Now let's look at calculations, right? So we said acceleration is change in speed over time, right? Change in speed over time. So we can use a method, this formula, which is saying acceleration is change in speed over time, to calculate acceleration, or we can calculate the gradient of this line. It should give us the same answer, the acceleration from 0 to 10. So if you're saying change in speed, our speed initially was 0 and it moved up to 5, so change in speed will be 5. So we start with the final speed that we had, the last one, 5 minus 0, that's the change in speed, we get 5, right? Time taken for that change to happen is from 0 to 10, which is what? 10 seconds. So you now say 5 over 10, you get 0.5 meters per second squared. So this is supposed to be the power 2, 0.5 meters per second squared. That's the what? The acceleration, right? Which means that our speed is increasing every second by 0.5 meters per second. That's the rate at which our speed is what? Is increasing. I hope it is making sense. Then acceleration, if you're using the gradient, we take 2 points on our graph, right? We take 2 points on the graph. So we can take, let's say, we want to take 2 points that are very exact on our graph. So we can take maybe this point, which is 0, 0, right? We can take point 0, 0, and then we can also take point 10, 5. So remember, when we say point 10, 5, what we really mean is x is 10, then y is what? Is 5, so this is 10, 5. The year x is 0, y is 0, so this point 0, 0. Those are the coordinates of this point and that point, right? And then we say now y2, which is the y here, which is 5, minus y1, which is the y here, which is 0, over x2. X2 is the x here, which is 10, over x1, which is the x here, which is 0. So 5 minus 0 becomes 5, 10 minus 0 becomes 10, 10 divided by 5 divided by 10 becomes 0.5 meters per second squared. So it means that the velocity is increasing by 0.5 meters per second every second that we are traveling. That's the acceleration that is happening. So that's how you calculate it. If you want to digest this and you need more time, please feel free to pause the video and then jot down some notes, try to digest it, and then you can move on. Now, when you're asked to calculate the distance traveled, like I said, you are using the area under the graph, right? So you can just divide your graph into 3. If you want to make the area calculations easy, you can divide the graph into this first part, right? Becomes part A, then this second part, this rectangle, becomes part B, and then this third part, this another triangle, becomes part C. And then you calculate the areas for here, for here, for here, and then you just add the areas and you get the total distance what? Traveled, right? So let's calculate the area of the first part and then the area of the what? Of the second part. So the area of the first part, which is the triangle, right? The first triangle here, you say half base times height. The base is what? 10, the height is 5, right? So you use these graduates that are given here. So 10, half of 10 times 5, half of 10, half times 10 times 5, you get 25. Then for this middle part, it's just length times width, which is like from here to here, it's 10, right? Times width, which is 5, so 10 times 5, 50. Then this one is equal to this one, so it's half base, half of 10, this is just 10, right? Times the height, which is 5, you also get 25. You add 25 plus 10 plus 25, you get 100 meters. That's the total distance that has been what? Traveled. Then the last thing that we want to do is we want to be able to recognize from the slope of a speed time graph when a body is in constant acceleration, constant velocity, and constant deceleration. So when a graph is like this, it means that the body is moving at a constant acceleration, right? Remember the one we just calculated was 0.5 meters per second squared, which means every second the velocity is increasing by 0.5 meters per second, right? The speed is increasing. So that's constant, means every second the velocity is increasing by the same value. That's constant acceleration when the graph is straight. When the graph is horizontal, it means there's constant velocity, there's no acceleration happening, there's no change in speed. Then when the graph is straight but it's going downwards, it means there's constant deceleration. The speed, the velocity is reducing by the same amount every second or every unit time. It might be every hour or every minute, every second, right? So that's what is happening here. So don't mind this one. This one is the correct constant speed or steady speed, constant velocity is this part. Then with moving with changing speed, there's changing speed, but this is constant what? Acceleration. That's the correct thing. So don't mind these things. I'll fix them. Plot and interpret a speed time graph. So before we get to the speed time graph, I want just to do a recap of the distance time graph. When distance is not changing, right, with time, so time is moving, right, but there's no change in distance, which is the vertical change, which means this object is at this one point, it's stationary, it's not moving, so it's just at the same point. So this is at rest. When distance is changing with time, right, this is uniform motion, right, this is constant speed, right. Then when distance is changing with time but it's moving like this, right, this is what non-uniform motion means. There's some acceleration that is happening here, right. The velocity is not increasing with time in a very constant way, right, in a very uniform way. There is acceleration, there's a change of what, of speed. So there's acceleration happening here. So as you can see that the graph, remember we talked about the gradient, right? So the gradient is increasing bit by bit, which means that the acceleration is also what, increasing, the velocity is increasing, and it's not constant. So, and the velocity is not constant, so there's some sort of acceleration that is happening here, because the velocity is not what, is not going to be the same. If the velocity is the same, the graph will be what, straight. But since the velocity is not the same, there is some sort of there's acceleration that is what, happening. Then here there is negative acceleration that is happening. It's deceleration, right, because the graph is then curved like this. So at this point where it's horizontal, it means that the object has stopped moving. There's no more change in distance with what, with time. So this is constant acceleration, this is constant deceleration. So if our graph was more curved like this, it means the acceleration would be higher, right? So the more it's curved, the more the acceleration, right? So even here, if we were decelerating and then the graph was just maybe more curved like this, means it was decelerating faster downwards here, right? The deceleration was faster, right? So that's that for the distance time. Now let's go to the velocity time graph or the speed time graph. Here it means that the velocity, this is the velocity and time, right? It means that the velocity is constant, there's no acceleration. Here it means that there is a constant acceleration, constant deceleration. This is non-constant acceleration. It's accelerating, but there is no it's not constant, so it's not constant, it's non-constant acceleration. So the steeper the slope, the higher the value of the acceleration, right? So if the slope is steep like this, means the acceleration is also higher. So it will make sense why I've put Isaac Newton's picture. So the story is that one day he was sitting under a tree, I think it was an apple tree, and then an apple fell from the tree, and then that's how he figured that gravity pulls everything to the ground, and then that's what causes the acceleration due to gravity. So when you drop something and it's dropping freely, there's nothing that is pulling it or pushing it, right? If it's free fall, the acceleration that is happening, the change of speed as it's falling down from the tree down until it gets to the ground is acceleration due to gravity. That acceleration is being caused by what? By gravity, right? So acceleration is not okay. The downward acceleration of an object is caused by gravity. Sorry, not usually. It's actually caused by gravity. This happens most when an object is in free fall, which means it's falling with nothing holding it up. Right? Nothing is pushing it up. It's just falling. Objects are slowed down by air resistance. Right? So if you're throwing something maybe into the sky, it's slowed by the what? The air resistance, because the air resists its motion upwards, right? Or sideways, whatever. There's upward. There's just air resistance. So even if a plane is trying to move this, there's air resistance that is trying to push it back, right? And that's it. Actually takes advantage of that principle so that the airplane can fly. So we're not talking about that right now. If you want me to talk about that, please DM me and I'll just do a separate video of that. So that's it, family. That's a wrap. We are done with this topic. I hope you guys had a blast. Until next time, School of Charles. This is your tutor Des. Bye. Peace.